how's it going everyone? Welcome back to Nerdlabs. In today's video, we're going to be making art with high voltage electricity. Now what we're going to see in this video is called Lichtenberg wood art, and people have been doing it for a while, mostly using either neon sign transformers, which produce about 15,000 volts, or microwave oven transformers, which produce about 2,000 volts. But today I'm going to try out a different way of doing it. I'm actually going to be doing it using a Tesla coil. Now what Lichtenberg wood art actually is when you blast wood with high voltage electricity after coating it in a conductive liquid. What happens is the electricity burns intricate lightning-shaped patterns into the wood in a completely random fashion, so each time you do it, it'll look completely different, and it's really beautiful. So, let's do this. And before I go on, I have been doing electrical engineering since I was 5, and have a complete understanding of electrical safety. Do not try this at home unless you understand how to do it safely. I also have my dad with me, who is a retired professional electrical engineer, so to make sure I stay safe. And with that in mind, let's go. The Tesla coil we're going to be doing this with is a vacuum tube Tesla coil that I built last year. Now, this uses a Pmac 3CX5000A7 vacuum tube, which is basically like a giant electronic light switch rated that can operate at 7,000 volts without burning out. Now this vacuum tube produces an electrical signal to pump a high-frequency electromagnetic field into this big coil of wire, which outputs about 850,000 to 1,000,000 volts out of this wire here. Now when I'm making Lichtenberg art with this, I actually have it hooked up to this, which is a pie tin hanging from the ceiling by strings. Now this has a metal nail on the bottom that actually directs the electrical arcs downwards into the piece of wood that we're using to make Lichtenberg wood art. And this pie tin just acts as a big capacitor that I use this jumper lead to hook up over to the Tesla coil. Now this is sodium acetate here. It's basically the chemical you get when you mix baking soda and vinegar. And since people normally use baking soda or salt dissolved in water for Lichtenberg wood art, it'll be interesting to see how a different ionic compound will change the results of the experiment. So I'm using this brush to paint it onto the wood to increase the wood's conductivity, as that will allow the electricity to properly flow through it. Alrighty, 3, 2, 1. Now the science behind these patterns is really interesting because it involves electricity trying to find the path of least resistance. Resistance is a measurement of how much electricity can easily flow through a material. For example, a piece of wood has an extremely high resistance, air has an even higher resistance, water has a pretty low resistance, and water with lots of ionic compounds, chemicals that contain an ionic bond between a metal and a non-metal, is extremely conductive and will let electricity flow very easily.
Now, if we spread water containing ionic compounds on a piece of wood, it'll make the surface of the wood conduct electricity and allow electrons to flow through it. But wood is a natural material, and it's extremely imperfect in its structure and chemical composition. So even when you put a conductive liquid in it, some spots will still conduct electricity better than others, and some will be very resistant to the flow of current. So if we hit the wood with high voltage electricity, which will burn the wood wherever it tries to flow through it, then we can actually see the patterns formed as the electricity goes in a straight line, then hits a spot of higher electrical resistance where the wood doesn't conduct electricity as much. So it tries to branch around this spot and find the path of least resistance to the ground, thus producing beautiful patterns and allowing us humans to visualize the flow of microscopic electrons in real life.